Hi, I'm Zhang Qiang from the RTU Center, and I handle RTU products and pre-filled products. Our products are introduced from three aspects. 1, product types, specifications, and models. 2, equipment process flow and advantages. 3, laboratory inspections. Let's talk about pre-filled sealing products. The product has several specs. The first item is a pre-filled syringe with a needle, followed by a lure lock. Our needle products are primarily available in a standard 1 ml size and a longer 1 ml version. Next, the 2.25 ml and 3 ml specifications. Then we have a 1 milliliter standard and a 1 milliliter long version for our lure lock. Next, we have sizes of 1.5 ml, 2.25 ml, 3 milliliters, and 5 milliliters. Then our entire process is molding, pin insertion, cleaning, followed by heat source removal, silicone oil spraying inspection, including our 360-degree appearance and dimension inspection, and heat source elimination. Install the protective cap and check the height deviation of the cap. Create the nesting box and nesting board as per the specifications. Put in the inner and cover paper, then seal the nesting box with heat. Engrave, check, bag, package, sterilize, store. This is glass pre-filling. Let's talk about COP products. We have COP pre-filled products available in 3 main specifications: 1 milliliter standard, 1 milliliter slender, and 3 milliliters. The main processes we utilize for injection molding are 5 milliliters, 10 milliliters, and 20 milliliters. Then cleaning. Remove the heat source. Spray silicone oil, check dimensions and appearance from all angles, assemble the nesting board and box as per specifications, then add inner and cover paper before sealing the box. Coat and wear a double-layer bag, then sterilize and store. The above is an introduction to COP pre-filled products, and next I will introduce our RTU products, starting with the cartridge bottle. The specifications of the cartridge bottle mainly include 1.5 milliliters, then 1.8 milliliters, and 3 milliliters. The key process is injection molding, then wash and remove pyrogens, then spray silicone oil and check. After rolling the lid, we check its size all around and then put in the nesting box and papers. Seal the box and test it, then coat and check. Sterilization. Storage. Following this, I will introduce a different type of RTU vial product, focusing on the main specifications, which include 2 ml, 6 ml, 10 ml, 20 ml, 30 ml, and 50 ml sizes. The main craft refers to the blowing technique in cleaning. Get rid of the heat source. 360-degree size check. Next, install the nesting box and board along with the papers and check. We seal it all and then use ethylene oxide for sterilization before putting it away. Then introduce the product quality assurance. First up is our purification workshop, mainly D class and C+A class. Our clean room is designed and constructed in strict accordance with FDA requirements, including our on-site controls, which are also implemented according to FDA standards, as well as our electronic signatures and audit trails. Then, the workshop's temp, humidity, and pressure tracks air exchanges, fully automated, logged in SCADA, view workshop status anytime. Now, I will briefly mention that our clean compressed air meets the FDA's requirements. During the whole process, we selected only leading international brands of oil-free air compressors, which encompasses our 3-stage filtration system and the final filter for sterilization. The cold dryer is a blower-hot dryer that ensures clean compressed air. This section also follows FDA requirements regarding the testing of clean compressed air. Oil and water levels, including dust particles and microorganisms. Now, I will briefly introduce our water system, designed according to FDA standards, which includes pure water exchange, injection water, and a distribution system. We comply with pharmaceutical standards in our testing, using online monitoring for conductivity and flow, meeting FDA requirements with electronic signatures. Here is an introduction to our public facilities and equipment. Now let's move on to our overall process equipment. Let's start with the molding process. Molding and size check. Control the annealing curve to stay within 5 degrees. A complete 360-degree inspection of the appearance using plastic trays uploads data to the SCADA system in real time and calculates CPK and OEE, creating batch reports. The second process is our pin insertion process. In terms of the pin insertion steps, we apply glue and then test the pull force, which also includes measuring the needle's offset and checking for burrs. Needle verticality includes length, glue height, and glue depth. They all require strict standards, and everything is checked online with full accuracy. 360-degree inspection data uploaded to SCADA. In real time, we compute the current CPK and OEE, creating batch reports that provide an analysis of our CPK and PPK data. It includes the quality module on the SCADA system and will record in real time. The last step we take is the cleaning process. Cleaning, in short. Clean 4 injection waters and 5 compressed airs, spray silicone oil, and check for its amount. Ignoring heat sources, we check the size from every angle. Clear detection, needle offset, and burrs. Flange size check, cap installation, and cap pressing. Next, we will conduct a check on the offset and height of our helmet. Check the cap length and its overall integrity. Fully inspect the helmet's look. Once the appearance check is clear, nest boards and boxes are put together according to the specifications. Pack, insert inner and cover papers, then seal. After sealing the nest box's surface, we will check online for any appearance flaws to ensure it is fully sealed, including engravings and double-layer breathing strips. Upload detection data to SCADA. Calculate CPK and OEE now and make batch reports. It includes the quality module on the SCADA system and will record in real time. Here is an introduction to the equipment. Also, let me briefly introduce our KENAS lab, where we follow ISO standards for our RTU and pre-filled products. IBB needs checks on appearance, size, and production testing, including physical and chemical tests. Next, the microbes and controls will be tested. Above is a brief lab intro. Let's talk about the BOM raw material suppliers. The glass tube we are utilizing is mainly sourced from Schott Company, and regarding these pistons, Kappa. After that, the protective cap and piston are sourced from Stelmi, along with our UV glue for application. UV glue supplier. The materials used are Loctite, and for the silicone oil, we selected Dow Corning. The stainless steel needle is from Nipro, and all other components are self-produced. Here is an introduction to the BOM. Sterilization methods include ethylene oxide, irradiation, and moist heat after production. Now let's introduce the advantages of RTU products and pre-filled products, along with the overall planning. All of our upper-level machines utilize this SCADA system, which records and analyzes all data by batch, including CPK, PPK, electronic signatures, and audit trails. Then it includes our equipment OEE and all our data reports, which can be viewed anytime and anywhere according to permissions. Pharma firms can check progress. Thus, our project can become entirely unmanned, data-centric, and smart. Standardization and systematization.